So in this video, I have another how video for you. We're going to talk about the schema, the meta AI, and the human-computer interface. So let's jump into it. So the power of the AI compiler lies in its generality and its flexibility. So what exactly do I mean by that? Well, what I'm showing you here is what we call the schema of the AI compiler. And what the schema is it's the language that the AI compiler speaks. So let me use an analogy to our brain. So our sense organs, our eyes, our nerve endings, our olfactory system converts data in the real world, so light or touch, and it converts it into an electrical signal that the brain then processes. And so the brain doesn't need to know if the signal came from the eyes or touch. It processes it all the same way. And so the same thing is true of the AI compiler. It doesn't need to know if it came from a human, a machine, text, audio. It all gets converted into the same schema representation. So let me just give you an example. So if I want to do object detection, what I could do is just specify an image schema input and a bounding box schema output. And then I can automatically do object detection. And what this does is it automatically generates two what we call compute primitives. One is it's a human compute primitive, and essentially what that is a user interface where a human can click and draw a bounding box, among other things. The second thing it generates is what we call a machine compute primitive. So it creates a primitive that a machine can understand, so it also can complete a task. And so going back to the generality and flexibility point, you can specify any combination of input and output and automatically generate a task that both humans and machines can complete and the AI compiler can execute and understand. So just with the schemas on your screen, there's 8 input schemas here and 8 output schemas, and these are just unique combinations. So just with these schemas here, the AI compiler can create and execute 1.6 billion different tasks. So that is quite powerful. But in reality, we have 16 different input schemas and 48 different output schemas, and we're adding more every day. And so that gives you 2.6 times 10 to the 74th power different combinations. And just to put that in context, the amount of atoms in the universe is about 10 to the 78 different atoms in the universe. And so the amount of tasks the compiler can automatically generate and execute is only about 10,000 times less than the number of atoms in the universe. So that just gives you an idea of the generality and flexibility of the AI compiler. Okay, so let's go a level down and talk about exactly how we can generate these tasks. And in particular, I want to talk about the meta AI module. So if you remember when we were talking about the AI compiler, there was the trainer module, which had the meta AI system, and the meta AI system could automatically create AI machine learning models that can complete the task. And over time, it would generate more and more machine learning models. And over time, it would become more and more automated, more and more scalable, and less and less expensive. Okay, so how does this work? Well, you have your input schemas, and each of those input schemas goes through a decoder. And so every time we implement a new schema, we also have to implement a new encoder. And all the encoder is a neural network that takes text as input and generates a vector. So for example, one type of encoder for text is an LSTM, and LSTM takes your textual input and generates a vector. Or the satellite encoder takes satellite imagery as input and outputs a vector. These vectors then go into a meta AI combiner. And so, for example, if let's say you had image and text input, well, each of these encoders would output a vector, And then those vectors would get concatenated in the combiner and pass through a fully connected layer. So you can have any combination of inputs and they would get passed through the same neural network architecture of the fully connected layer. Then the output of the combiner goes then into decoders, which is essentially the inverse of the encoders, and it takes the output of the fully connected layer of the Meta AI combiner, and it generates the output data type from that. So that, for example, the text decoder takes the output vector of the fully connected layer, runs it through an LSTM, and generates text. And so what happens here is you can see that for any single combination of inputs and outputs, you can create a neural network architecture that can take you from the input schema to the output schema. So this is, again, what I mean by the generality and flexibility. And then because these things are broken up into different modules, you can also harness things like transfer learning and using architectures across different tasks and the different data types, and this just gets more and more powerful over time. And so when we measure the impact across all of our customers, we get about a 62% cost reduction, again, over all of our customers. And we see some customers get more like a 99% cost reduction, some customers more like a 20% cost reduction, but on average, we see the automation effect due to Meta AI around 62%. So what I'm going to do now is just go through some examples to make this a little more concrete. So if you wanted to create an image Polygon task that the AI compiler would execute, all you would simply do is specify an image input and a Polygon output. And again, it automatically generates the human compute primitive, which is just an interface that any human can use, and the machine compute primitive, and the AI compiler executes it because it's in the language that it understands. Doing 3D object detection on videos is as simple as specifying a video input and a cuboid output. You can make more complicated tasks by just adding more schemas, in this case on the output. So to do document OCR, you choose a data program or a task with image input schema, bounding box output schema, and a structured output schema. And you can have a machine learning model that can automatically do document OCR and a human labeling task for document OCR. If you want to do machine translation, obviously you choose text input and text output as a template. But the cool thing is, with the same template, we call them data program templates, you can also do, in addition to machine translation, you can automatically generate a machine learning model that can do sequence dialogue modeling. And so, again, the power is in its flexibility and generality. So based on the parameters you add and the data you add, you can have completely different tasks. So for example, with the exact same schema and architecture, you can do machine translation or sequence-to-sequence dialogue modeling. And the exact architecture of the machine learning model will change and the hyperparameters will change, but for the AI compiler, it thinks of these as exactly the same. You can do named entity recognition by choosing a text span output and a text input. And again, similar to the previous example, with this same template and same input and output schema, in addition to named entity recognition, you can do parts of speech tagging, IOB tagging, key phrase tagging, topic extraction, etc. And these are all things that we've done for our customers, and it's a very, very minimal change, so we can complete all these things very quickly. Or a lot of our customers ask for entity relationship annotation. And again, with this, you can do entity disambiguation, co-reference annotation, discourse annotation, phrase structure relationships, all things our customers have asked us to do. And we can deliver them instantly because we've already built up the schemas to handle this. Multimodal tasks, again, are as trivial as specifying different inputs and giving and for a given output. So to do visual question answering, you would just specify text input, image output, and text output. And again, you automatically generate a machine learning model that can do visual Q&A. And maybe it starts off really good because it's using this neural network architecture from maybe another example that you have. Doing one-shot learning with Siamese networks is as simple as specifying 2 image inputs and a binary output, and you would add additional parameter to make it a Siamese network that you tie the weights of your architecture. Again, you can do speaker identification, and even things like classical regression is just a matter of specifying the input. Okay, so that was an overview of the schema of Meta AI and the human-computer interface. In the next video, we will talk about the data engine. So I will see you then.